Good morning and welcome back to another video. And in today's video, we're going to be looking at functions. So function codes pretty much when you build a function, you're going to create another script where those equations are going to be, and you're just going to, in your main script, define some parameters. Okay. So in the function code, you're going to have output equals the function name and then input. So we're going to build our own function that solves this equation right here. All right. So we're going to define x equals 10. And then we're going to say output equals, and we're going to call this poly of x. Okay. But we need to build the function code. So if we go up to File, New, Function, okay, we can type our function. Let's call it poly. All right. And I'll give you a bunch of stuff. I'm just going to delete all this. Okay. So we have in the function code, you're going to write function. This is going to be, let's call it output. Oops. And then the file name. And I'll delete the space. And then your inputs. And here I'm going to say x. All right. And then I'm going to copy and paste that equation, which is right here. And I'm going to say output equals that. All right. And then I'm going to save it. Go back to my main script. And I'm going to save this. And I'll just do it in the desktop. And I believe it's tutorial. Give me 1 second. We are now on tutorial 7. Change directory, and we ran the code. So let's go to our command window, and we forgot one important thing. Our poly function code, this has to be saved in the same location where your main code is. All right, so I just resaved it. So make sure you do that. Okay. So run it. And now in our command window, we type output and we get our answer. Okay. So recap. When you do, we built a function code that works with our main code. So we wanted to have a function called poly. All right, that had an equation or a polynomial like this, where the input x is put in and we get an output here. Okay, so the way we build it is you say function output equals the function name, the input, and then here's your equation that you're looking at, and then end function is the last. Make sure you save this where your main code is, okay? And then you can just say x equals 10, and then the output is your function name, x, and you'll spit out an answer. This sometimes is used when you don't want your code to be so much longer, or if you're executing that a lot, you can just build this function code and boom, then it becomes like a built-in function, all right? Anytime you change, so say you change this to the 4th, you have to hit save. Otherwise it doesn't update. It doesn't save itself. Cool. All right. So let's just make another one. So let's make the quadratic. All right. So let me copy and paste these. So here's a different one. So quadratic function. So say we have x squared plus 5x plus 6 equals 0. We want to find what x is. So we're going to use the quadratic equation. Let me just show you the equation. All right, but the coefficients are 1, 5, and 6. And we have two answers. So answers 1, answer 2, function name, and our inputs. Okay, so these are our outputs. We're going to have multiple outputs. Function name, and then A, B, and C are our inputs. So let's save this. Let's do File, New, Function, and it's going to be called Quadratic. And then click OK, and then I'm going to just delete all of this because we don't really need any of this. All right, let's first save it on the desktop wherever you're saving it. So save it and replace. Okay, we were already on the desktop, so that's why. And then here it's going to be what? Answer 1, comma answer 2, right? Just like our main code. Here, if you want, you could just copy and paste that. Okay, quadratic, and then inputs, we have 3, right? A, B, and C. And then the quadratic equation has 2 equations because it's answer 1 and 2, and they're right here. So remember, it's minus b plus or minus square root of b squared minus 4ac over 2a. Save it. Go back to our main code. And then let's just take that out and run it. And let's see what happened. Did I spell it wrong? I might have. Quadratic. Oh. Let me save it as that. Save it. Tutorial. Let's try it again. Maybe we got another issue. Called from, let's see, sometimes, let's just close this and reopen Octave. Sometimes I've noticed that. Let's see, where are you? Right here. Go back to the editor. So here's the quadratic. Go back to here. Let's see if we're getting the same issue. Nope. Okay. Yeah. There is still some funky stuff going on that I haven't figured out what's going on. But if it gives you an error and it looks right, if you can't find this, just close it and restart it. Okay. So command window. All right. So we ran it. Run it again, and we end up with -2 and -3 for our answers. So again, recap for this. We had a function called quadratic, which is -b plus or minus square root of b squared minus 4ac over 2a, with inputs of a, b, and c. Function name is quadratic, and we have answer 1 and answer 2. Ours are outputs. Okay, so outputs are on the left of the equal sign, and then our inputs are on the right hand of the equal sign. And again, anytime you change this, you got to make sure you save it. In your main code, you have your outputs, your function name, and your inputs. Cool. All right, let's try one more, see if it'll work. We're going to just build an engineering quick problem. So number 3, so say your acceleration is 0.5 t, and we're going to write a function called to calculate acceleration, velocity, and distance for an array of t values. Okay, we don't worry about that. But it has initial velocity of 0, initial position of 0, initial time of 0, sorry, final time of 30, and a delta t of 0.1. Okay. All right. So this is going to be our we have our T matrix from T naught to TF, and then here's our outputs. Here's going to be the function name, and then here is our inputs. So we have 4 this time. Let's save it. Let's create a new function. So file, new function, and it's going to be called motion. Make sure I spell it right. Click OK. And again, I'm going to delete this stuff. So it's motion. Go back to our main code. We're going to copy paste this right there. Oh. I don't know what just happened. There. Okay. And then what was our inputs? These 4. Copy these. Paste those right in there. And then I have the equations. I'm just going to do a shortcut way just for now. So acceleration is 0.5 t. Velocity is t squared over 4. And position is t cubed over 12. And again, I have these dots because this t is a matrix, and technically you don't really need it on here because it's just a constant times t, but here, because this is t times t, or t squared, it wants to pick that single number in each array and square it. And same with this. This is a matrix. T is a matrix, and you want to take, like, I think it's going by 0.1, like 0.1 or 0.2 cubed. Okay. All right, let's save it. I believe it got saved in the desktop. Yep. Go back to here, and let's just run it to make sure it works. See if we got any errors. Nope. And let's just type A. Yep. B and D. Oh, I think we might have used S. Okay, cool. Yep. All right. And now we can plot. We'll do subplots. Let's review subplots. I'm just going to paste it on here so you can see. And my keyboard is funky. All right. So here's figure 1. And then I'm going to plot A versus T on subplot 1. So if you remember subplots, I'm going to do 3 of them. And then this is the kind of orientation. So we're going to go like top down with 3. And then here, it's going to plot on the first subplot. Okay? So T is your X. This is your Y variable. I did a line width of 2. And you got time for label, acceleration, and then title. And then again, 312 is velocity, and 313 is position. So let's run it. And we get our graph. With titles, with labels, we got acceleration, velocity, and distance. Pretty cool. All right, so just to recap. Functions. Inputs are on the right. Outputs are on the left of the equal sign. And then you have your function name. So in this, we have no equations. All we have is equations in our function code with outputs, function name, inputs, equations, outputs on the left of the equal sign, inputs on the right side of the equal sign. Make sure anytime you change this, you save it, and make sure that this function code is saved in the same location as your main code. Okay? And then you just run it, and then do whatever you need with after it. So here I just plotted with this. All right, I hope you enjoyed, and good luck. Thank you.